Today we are going to be doing the 35th Project Euler problem called circular primes, where we're trying to figure out how many circular primes there are under 1 million, where a circular prime is defined to be a prime where all the rotations of the digits are also prime. Okay, let's get started. So first off, let's write a function that figures out if a number is prime. So if the number is less than 4, it's only going to be prime if it's 2 and 3, which is if the number is greater than 1. Okay, then we're going to check if the number is divisible by 2 or divisible by 3 for the optimized primality test that I will be using. And then, given that it's not divisible by 2 or 3, we can safely just check the 5 mod 6 and 1 mod 6 of all the way up to 1 plus the floor square root of the number, which is denoted by I square root here. Because I square root is the floor square root, and then we add 1. And then we're going to do 6, so the step is going to be 6. And then we're going to check if the number is divisible by I, which is going to represent the 5 mod 6, because it's starting at 5, and then we're going to increment by 6. And then we're going to have another check for the 1 mod 6, which is going to be the I plus 2. So it's going to be plus 2 off of the 5. So it's basically starting at 7, and it's going to be incremented by 6 right here. So if these are true, it's going to be a non-prime, and then otherwise it's going to be a prime. So we can check that against a really slow one, but really like a function that we can know is correct, which is this other one that I'll write. So we'll copy over this stuff from the first one, but otherwise we can say for I in range 2 num, if num is divisible by I, then we return false, and then we can return true. And then we can just test this out really fast. Okay, so we have some differences right here. Not sure why that is agreed. Oh, okay, that should be 0. Okay, looks pretty good. Doesn't seem like there is any discrepancies. Oh, we have some discrepancies right here. Our first function is saying that 5 is prime, even though it is not. We're starting at, oh, range. Oops. Okay, it's looking good now. Okay, so now we'll write a function to shift the numbers over. And then we will want to have a number that we can input to tell it how many times to shift. So if we're shifting 0 time, then we're just not changing the number, so we can just return the number. And then for however many times we're shifting, we can first declare like a string representation of the number so that we can use indices. And then we're really just trying to take the last sum number of digits, and we're inputting to the end of that the first sum number. So we're going to take num at negative negative shifts. Now we're gonna go num through negative shifts, and then we're gonna add num, oh no, not num, string representation. positive representation, and then all the way up to the negative shifts. So we can test that again. We can just say I shift I 0. That was pretty good. And then twice. I don't think that'll work. Oh, I guess it works. Okay, twice. Okay, well these are 2-digit numbers, so let's go up to 1000. Okay, so this shifted twice. We'll go back one and then here. Okay, that's nice. Let's go. So now, for each number under 1 million, we can say for j in a range, we're going to take however the length of the number. So we'll go from length string of the number, and then we say, okay, we check if it's prime. So if it's not prime, we will say that we're I, and then we're shifting it by j. If it's not prime, shirt, bro. And then if it's not prime, we say break, so that we don't have to compute so much. And then we can say if j is equal to length of string of I minus 1, which means it's the last digit, then we can say total plus equals 1. And then we can say print total. Boom. 55, that's our answer. And then we can go to a GitHub repo that has the answers, and there it is, 55.
Engine start, no problem. 5 minutes. Tidin, problem engine.
Ублюдок, мать твою, а ну иди сюда, говно собачье, а решил ко мне лезть, ты.
What the hell?